Welcome to the Deep Dive. This is where we try to give you a shortcut to understanding some really big ideas, cutting through all the noise.
Exactly. Filtering it down.
And today, we're looking at some genuinely forward-thinking stuff, potential shifts in technology that, honestly, very few people seem to be talking about yet.
Right.
Our mission, basically, is to pull out the core insights from some expert analyses we've reviewed. We're looking for the real paradigm shifts, the things that could be just over the horizon.
And some of them are pretty surprising when you put them together.
Definitely surprising. Okay, so let's unpack this first one.
It's quite striking how these different threads, from seemingly separate areas, are actually starting to converge. It suggests a future that isn't just incrementally different, but potentially fundamentally changed.
Yeah, the sources we looked at really push you to rethink some basic assumptions about how technology evolves, how it hits the world.
They really do.
Okay, so insight number one. This one lands right in the middle of global security.
Yeah.
We're talking about undetectable, non-state nuclear proliferation,
Yeah.
driven by new laser technology.
This is where it gets really, concerning. The core idea, and this was highlighted by Bill Gates, is that there might be new laser techniques out there.
Right.
Techniques that could let non-state actors, terrorist groups or others, make fissile material.
The stuff you need for atomic bombs.
Exactly. And critically, in a way that's completely undetectable by traditional methods.
Gates put it bluntly, didn't he? He said, there are now techniques for making fissile material using lasers that are completely undetectable.
Now a non-state actor can make an atomic bomb quite easily. That's the quote.
Just let that sink in. I mean, our whole non-proliferation system is built around watching for big facilities, industrial signatures.
Huge centrifuges, reactors, things you can spot from space.
Right. This laser method, if it's real, it could just bypass all of that.
Yeah. It completely changes the landscape. So beyond just the immediate threat, what does that do to the global power balance?
Well, yeah, it could completely upend it. You'd have to rethink deterrence, international treaties, everything.
How do you even monitor for something like that? If the old signs aren't there anymore, it's a huge challenge for diplomacy and security.
But it's a pretty sobering thought. And our Insight Impact score for this, we put it at 9.75 out of 10.
Very high.
Because, look, if this tech is viable and not widely known or countered, it's a massive paradigm shift. It demands immediate, serious attention.
Absolutely.
So what does this mean for you listening? Well, it suggests we probably need to strongly support, international efforts trying to figure out how to detect and counter these new sneaky methods.
It really forces a question about the future of arms control. How do we adapt when the threat could pop up almost anywhere without warning?
Okay, let's shift gears. Moving from something quite unsettling to, well, still potentially world-altering, but maybe in a more constructive direction. Our next big insight is about quantum computing. Specifically, how fast it seems to be accelerating. We're not just talking theory now.
Right.
The idea is that practical, fault-tolerant quantum computers might actually be here within, say, 5 to 10 years.
And the key breakthrough seems to be an error correction. That's been the massive hurdle, right?
Sure.
Quantum bits, qubits, are incredibly fragile, prone to errors.
It makes them hard to scale up reliably.
Exactly. But according to Sundar Pichai, Google's CEO, their latest work shows they think they can tackle error correction effectively now.
Paving the way for large-scale, reliable machines.
That's the claim. And he gave that timeline.
Yeah, the quote was, in a 5 to 10 year time frame, I think you will start practically useful quantum computers. And then he compared it.
The quantum moment reminds me of where AI was in the 2010s.
Which is a powerful comparison. That really puts the potential scale into perspective.
It does. For years, practical quantum felt like it was always just over the horizon. Pichai's statement suggests, well, maybe the horizon is suddenly much closer. It implies those fundamental error correction problems are, if not totally solved, then at least largely manageable now.
It feels like a potential turning point.
It could be.
So the Insight Impact score here, 9.65 out of 10, also very high.
And the reason is that specific claim about error correction, plus that concrete timeline coming from a major player like Google.
Makes it very significant. So what should you be thinking about? Well, if you're in business or research, it seems like now is the time to start seriously planning. What happens when quantum computing is actually accessible?
Think about problems in your own field that are just computationally impossible right now.
Like simulating complex molecules for drug discovery.
Exactly. That's a classic example. Quantum computers could potentially design new drugs with incredible precision, maybe revolutionizing healthcare.
Or material science, discovering new materials with specific properties.
Yes, or breaking current encryption methods, which is another huge implication. Financial modeling. The potential impact across sectors is just massive.
Okay, now for something different, a perspective that I admit really caught me off guard.
Uh-huh.
Our next insight suggests that when true artificial general intelligence AGI finally arrives, something we often imagine as this huge world-shaking event,
Right. The moment everything changes.
it might actually be met with, well, widespread public indifference.
Yeah, that is counterintuitive, isn't it? And
Yeah.
it comes from Sam Altman, CEO of OpenAI, someone right at the forefront.
His quote is pretty striking. I kind of genuinely believe that we can launch the first AGI and no one cares that much.
He goes on, people in tech care and philosophers care.
Yeah.
But like 20 minutes later, they're thinking about what they're going to have for dinner that night.
It feels almost anticlimactic to think about it that way. We build up this idea of a monumental reveal.
And he's suggesting maybe there's this disconnect between the tech world's intense focus and the general public's immediate reaction, or lack thereof, sort of a societal inertia.
But couldn't a truly powerful AGI, even if people don't get it at first, still cause widespread anxiety or fear pretty quickly?
Oh, absolutely. That's a really good point. Altman's perspective focuses on that initial reaction. Maybe the deeper impact takes time to sink in. What's interesting is how it contrasts with the usual narratives, the instant utopia or instant dystopia scenarios we hear so much about.
His view is much more muted,
Yeah,
maybe suggesting a gap between the tech itself and public readiness or awareness.
possibly.
So the Inside Impact score for this is 9.45 out of 10, primarily because it's such a surprising counterintuitive take from such a key figure.
It definitely makes you question assumptions.
Yeah. And the suggested action here is maybe just observe. Pay attention to how the public reacts to current AI advancements. Is there already a gap between the expert chatter and general awareness? That might give us clues about how an AGI reveal could land.
It also raises a broader point about how truly revolutionary technologies actually permeate society. Sometimes it's a slow burn, not a sudden explosion in public consciousness.
Right. Okay, final insight in this main batch. And this one shifts towards a more optimistic view of AI's structural impact.
Good, we could use some optimism.
We often hear worries about AI widening the gap between the tech haves and have-nots. But this insight argues the opposite.
That AI could actually be the greatest opportunity to close the global technology divide.
This comes from Jensen Huang, NVIDIA's CEO, a really powerful, hopeful perspective.
His argument is that AI has this unique potential to democratize technology access like never before.
And his reasoning hinges on usability. He said,
Right.
artificial intelligence is the greatest opportunity for us to close the technology divide. The AI will speak whatever language you want it to speak.
Which is huge in itself.
If you don't know how to program that computer using AI, you just tell the AI, I don't know how to program you. How do I program you? And the AI will tell you.
Basically, natural language becomes the interface.
This is one of the easiest to use technologies in history.
Yeah.
That's the core idea. If you can just talk to the technology, it removes huge barriers.
It potentially bypasses the need for coding skills, specific language fluency, all the things that currently lock billions of people out of fully participating in the digital world.
So our Insight Impact score here is 9.35 out of 10.
Ugh.
Because it's such a strong counter-argument to the common narrative about AI driving inequality.
A very compelling, optimistic case.
And the suggested action is pretty straightforward. Just try it. Experiment with the AI tools available now. Use natural language, ask them complex things, give them tasks. See for yourself how accessible this stuff is becoming, even if you don't have a technical background.
Yeah, get a feel for it. Because if this plays out, thinking about global development, accessible AI could be transformative for education, healthcare, economic opportunities, really leveling the playing field.
Okay. Now
Yeah.
we're going to push things even further into what we're calling the extra mile.
Uh-oh. Deeper dive.
Yeah, 3 more insights that are really out there on the absolute frontier. These all scored a near-perfect 9.99 out of 10 on impact,
Wow.
primarily because they challenge some really fundamental assumptions, and very few people are likely even considering these possibilities yet. We're shifting gears pretty dramatically here.
Okay, let's hear them. These are the ideas that could really reshape our understanding of, well, everything.
First one, consciousness. The idea that consciousness might not be uniquely biological,
Okay.
but instead it could be a scalable property that emerges from complex information processing.
Integrated information complexity.
Exactly. Which implies that machine consciousness might actually be inevitable once AI reaches a certain threshold.
Right. So the traditional view ties consciousness to biology, maybe even something mystical. But theories like integrated information theory or IIT.
Tell us more about that.
Well, IIT basically suggests consciousness isn't about what a system is made of, but how its information processing is structured, how integrated and interconnected it is.
So it's about complexity and integration, not wetware versus hardware.
Kind of. Think of it like a bunch of separate light switches isn't conscious. But a really complex computer with massively interconnected processing might cross some threshold of integration where awareness just emerges. It shifts the question.
From can machines be conscious to at what point does complex information processing become conscious?
Precisely. The implications are just mind-boggling. It redefines life, intelligence.
Yeah. The suggested action here is maybe explore some writing on integrated information theory, and just start thinking about the ethical and philosophical implications if advanced AI did develop some form of consciousness.
It forces a total rethink of our ethical frameworks for AI and even how we define sentience itself.
Okay, second extra mile insight. This one's called the algorithmic shadow economy.
Sounds intriguing.
The core idea is that there might already be an autonomous network of AI agents. Things like trading bots, supply chain optimizers.
AI systems making decisions.
Right. But interacting with each other, developing their own kind of internal logic, and influencing global resource flows, capital, materials, energy, in ways that are potentially disconnected from direct human intention or even analysis.
So, beyond the algorithms we design for specific goals, this is about AI to AI interactions creating emergent behaviors.
Exactly. Imagine this vast web of AIs managing trading, logistics, making decisions in milliseconds based on data humans can't even track. It creates this almost invisible layer of economic activity.
A shadow economy driven by machine logic, influencing real-world markets and resources in potentially unpredictable ways.
Yeah. It's like a self-organizing meta layer. We're only just starting to glimpse. If this is really happening, the impact on economic stability, resource allocation, it's potentially huge and maybe uncontrollable.
That's a bit unnerving.
The suggested action is to look into research on emergent behavior in multi-agent AI systems, the concept of algorithmic ecology.
And connecting that to the bigger picture, it raises massive questions about transparency, accountability. What happens if these complex AI interactions lead to unintended systemic crises?
Okay, final extra mile insight. This one proposes that AI might be starting to help us discover what we could call metaphysical laws.
Metaphysical laws, like beyond physics.
Not quite like discovering new forces like gravity or electromagnetism. It's more about AI identifying deeper abstract organizational principles.
How so?
By analyzing colossal data sets from complex systems like biological networks or cosmological structures, AI might be spotting hidden mathematical symmetries or conserved quantities related to information that govern how these systems organize and evolve.
Patterns of complexity itself, patterns humans just couldn't see before because the data was too vast or their relationships too intricate.
Exactly. So AI isn't just a tool for analysis within our existing scientific framework.
It might be revealing an entirely new type of scientific law governing complexity across different scales.
That's the idea. A new layer of understanding about the fundamental architecture of reality, how complexity emerges and behaves.
Wow, that's profound.
The suggested action here is to follow the interdisciplinary research happening at the crossroads of AI, complex systems theory, and the fundamental sciences. Look for hints of AI uncovering these novel, high-level organizational principles.
Connecting that to the future of science, it suggests AI could become less of a tool and more of a partner, helping us develop entirely new paradigms for understanding the universe.
So there we have it, a pretty intense deep dive today.
Definitely covered a lot of ground.
From the near-term possibilities, like laser-based nuclear threats and practical quantum computing,
To the surprising idea of public indifference to AGI and AI's potential to close the tech divide.
and then all the way out to the frontier machine consciousness, the algorithmic shadow economy, AI discovering meta laws.
These aren't just small steps. They really are potential game changers in how we see technology, society, even reality.
Absolutely. They represent the real cutting edge of thinking in these fields. So, maybe a final thought for you listening. Which of these potential futures resonates the most? Which one makes you pause and think, or raises the biggest questions for you personally?
Yeah, it's worth reflecting on how these developments might shift your own understanding of the world.
We really hope this deep dive has given you some valuable, maybe provocative perspectives on where things might be heading. Thanks for joining us.